All right, good news, chapter 6 is going to be shorter. It's not going to be as crazy as chapter 5. And that's because we did, if anyone did the test or looked ahead, we did a bunch of stuff already for chapter 6. So now that we kind of went crazy on chapter 5, 6 should hopefully start to click and will help reinforce some stuff that we learned in 5. Good? All right, chapter 6 is applied networking. So 5, we learned the basics. And here, now that we've learned those terms, etc., we're going to enhance or build on top of that. Easy day? All right, we'll hit escape to go to 6.1, which I believe starts us off with videos. It does indeed. All right, here we go.
In this video, we are going to examine Ethernet MAC addresses. But first, let's begin with an analogy of Talithia wanting to communicate with Jeremy. Talithia and Jeremy are the only two people in the room, within hearing distance of each other. So without having to mention Jeremy by name, Talithia just asks, "Hi, how are you?" Jeremy knows Talithia is talking to him and replies, also without mentioning Talithia by name. But what if there are more than just two people in the room? Now if Talithia says, "Hi, how are you?" each person in the room is wondering who Talithia is speaking to. To ensure that Jeremy knows Talithia is speaking to him, Talithia will include Jeremy's name in the message. "Hi, Jeremy, how are you?" Now Jeremy knows Talithia is talking to him and will respond using Talithia's name when speaking to her. Ethernet LANs use MAC addresses, media access control addresses, to accomplish the same thing. Every NIC, network interface card, has a unique 48-bit MAC address embedded into the card, represented in hexadecimal notation. Also known as a physical address, the MAC address never changes and will be the same wherever the device is located. An Ethernet MAC address has two parts. The first 24 bits represent the organizationally unique identifier, or OUI. This is the vendor or manufacturer portion of the address. For example, one of several OUI codes associated to Cisco systems is 00602F, as shown in the example. The second 24 bits are assigned by the vendor and unique to that particular OUI. For example, 3A07BC is unique to the vendor code 00602F. MAC addresses are 48 bits, with the OUI and vendor assigned portions each being 24 bits. MAC addresses are typically represented in hexadecimal, 6 hexadecimal digits for each portion. Ethernet MAC addresses are used for NIC card to NIC card communications on the same network. On an Ethernet LAN, there can be multiple devices. Similar to Talithia speaking to Jeremy, when a device on a LAN needs to communicate with another device on the same LAN, it is important that that device includes the MAC address of the destination in the message. Otherwise, the devices won't know who the message is for. When PC A sends a message to printer B, it will send it to printer B's MAC address. Routers on an Ethernet LAN will also have an Ethernet NIC, which means it has an Ethernet MAC address. Notice router D has two Ethernet NICs, one for each network it is connected to. That is what routers do. They connect to multiple networks. Router D's Ethernet NIC, with the address that ends in all Ds, is is only used to communicate with other devices on the same network, with PC A, printer B, and server C. Router D's Ethernet NIC, with the address ending in all E's, is used to communicate with devices on a separate network. This NIC cannot be reached by devices on the other LAN, such as PCA. When server C sends a message for a device on another network, it will send the message to router D's MAC address ending in all D's. Router D will forward this message out the appropriate interface towards the destination device.
All right, any questions on that video? It starts to go a little bit in depth. That'll prepare us for CCNA when we learn about what happens along the path, what happens at each switch, each router. But the main thing is the IP address stays the same wherever it's going, and the MAC address changes each hop or each router, which we'll dive into later. Next video.
The MAC address changes?
The MAC.
Yeah.
So the IP address will stay the same wherever it's going. But at each router, the source and destination MAC will change. Don't worry too much about that. That's going to be more in CCNA when we'll deep dive into that. Good, but for now, IP stays the same. What changes each router?
MAC address.
The MAC address. All right, next video.
Sometimes we need to communicate with devices that are on a different network. In this analogy, Talithia wants to ask Rick to go to lunch. However, Rick is in a different room. She gives this message to Alan, who is adjacent to both rooms, so he can relay the message to Rick. IP addresses allow devices to communicate with each other that are on the same or different networks. Routers are used to forward messages between IP networks. In this analogy, each room would be a different IP network, and Alan would be the router. IPv4 addresses are 32-bit addresses represented in dotted decimal notation. IPv6 addresses are 128-bit addresses represented by colon-separated hexadecimal notation. The difference between decimal, hexadecimal, and binary is that the decimal number system is base 10, having 10 digits, 0 through 9. The hexadecimal number system is base 16, having 16 digits, 0 through 9, plus A, B, C, D, E, and F, which equate to decimal base 10, 10 through 15, respectively. The binary number system is base 2, having only 2 digits, 0 and 1. IPv4 addresses are 4 decimal numbers separated by a decimal, with each representing 8 bits for a total of 32 bits. IPv4 addresses have a 32-bit subnet mask, also represented in dotted decimal notation. Subnet masks are a contiguous string of ones, with the rest of the mask being all 0 bits. This means that there are specific values that a subnet mask will have, such as 255.255.255.0. Subnet masks can be represented in slash notation using a slash followed by the number of 1 bits in the subnet mask. This is also known as the prefix length. Although the binary number system is beyond the scope of this video, the dotted decimal subnet mask of 255.255.255.0 would be the same as a /24 prefix length. An IP address has 2 parts, a network portion and a host portion. The 32-bit subnet mask is used to differentiate these 2 parts. The ones in the subnet mask indicate the network portion of the address, whereas the zeros in the subnet mask indicate the host portion. In our example, the 3 decimal 255, 24 1 bits, indicate the network portion of the IPv4 address. And the decimal 0, all 0 bits, indicate the host portion. Let's look at an example. We have two IPv4 networks, 192.168.1.0, with the 255.255.255.0 mask, and 172.16.0.0 with the 255.255.0.0 mask. Network addresses have all 0 bits in the host portion. Notice that all the devices in both networks share the same subnet mask, which means the network portion of their addresses are identical, indicated in blue. Their host portions are unique, indicated in red. PCA has the IPv4 host address 192.168.1.100. If PCA moves to a different network, its IPv4 address will change, and it will share the same subnet mask, along with the same network portion of its address, with all other devices on that network. As you can see, PCA now has the IPv4 address 172.16.3.0, with the subnet mask 255.255.0.0, which means it's part of the 172.16.0.0 network.
All right, any questions on that video? Should make some sense because we've already gone over that classful IPv4 chart, right, where we saw that the prefix identifies the network bits and the rest are the host bits. Abdul Shakur?
I understood at one point we were talking about the difference in the host and the network,
Mm-hmm.
and then when it actually was applying to it, I got lost.
We're going to go deep dive into that in CCNA. So, and we'll go more over it here a little bit. So hopefully it'll make more sense then. Think about what we did on the board the other day. If that, remember with the classful IPv4 chart, Alpha, Bravo, Charlie, Delta, that's primarily what I want you to be at right now. Good to go? Anything else? All right, I think we've got one more video. IPv6.
IPv6 addresses are represented in hexadecimal notation. Each hexadecimal digit is 4 bits, which means each segment of 4 hexadecimal digits would be 16 bits. There are 8 16-bit segments, with each segment separated by a colon. 8 16-bit segments gives us the 128 bits. IPv6 addresses are typically represented in compressed format. This is done using 2 rules. The first rule is that leading zeros of any 16-bit segment can be omitted. Notice that only the leading zeros in red are omitted. The second rule is that a single string of contiguous all 0 segments can be replaced by a single double colon. Notice that 2 segments, red, with all zeros can be replaced by a single double colon, also in red. An IPv6 address can utilize only 1 double colon. Here we see an example of combining both rules. Rule 1 omits the leading zeros, and Rule 2 allows us to use a double colon to represent 2 all 0 segments. Together, they give us the IPv6 address in compressed format. Similar to IPv4, IPv6 uses slash notation, the prefix length, to indicate the network portion, the prefix, of the IPv6 address. The /64 in our example indicates that the network portion of the address. This means the rest of the address in red is the host portion. The IPv6 address has all 0 bits in the host portion, indicated by all zeros in hexadecimal in red, or a single double colon, also in red. Let's look at an IPv6 example. We have two IPv6 networks, 2001 DB8, a CAD 100, double colon /64, and 2001 DB8, a CAD 200, double colon /64. Notice that all the devices in both networks share the same prefix length, which means the network portion of their addresses are identical, indicated in blue. Their host portions are unique, indicated in red. PCA has the IPv6 host address 2001 DB8, a CAD 100, double colon 77/64. If PCA moves to a different network, its IPv6 address will change, and perhaps its prefix length. As you can see, PCA now has the IPv6 address 2001 DB8, a CAD 200, double colon 77/64, which means it is now part of the 2001 DB8, CAD 200, double colon /64 network.
All right, there's a lot of numbers in that video. Numbers put us to sleep, apparently. We're going to go over IPv6 compression that they talked about in that video. And a lot of this stuff is going to be the basics for CCNA, but we'll cover all of that stuff. Who ya? All right, here's what we're going to do. That was a lot of videos. All right, so we made it through those videos. Now we can get back to lecturing. We all ready? We awake? All right, all right, all right. Okay. We've done a lot of stuff so far, right? And now we're learning about MAC and IP addresses, but we already have heard about these, right? So for example, layer 2 is what device? Layer 2, what hardware? Hardware. Layer 2 hardware. Switch. A switch, but a switch forwards information based off of what address? MAC address, aka physical. So if I were to ask you what is a layer 2 address, you would say MAC address, aka physical. Now what piece of hardware is layer 3? Router. What address is layer 3? IP. Also known as what? Logical. Okay, so let's break these down. Or let's break you down. Ooh. If you were to commit a crime, what is something they could use to identify you? Your fingerprints, right? So think about your MAC address. That's a physical characteristic of you. That's something that doesn't change, right? No matter where you go to Greece and you commit a crime, probably use Dawn. It's tough on Greece. Right? You go to Antarctica, you commit a crime, boom, your fingerprints all over the place, right? Now, before you joined the Navy, you all probably lived somewhere else, right? Maybe with your parents or on your own, in a van down by the river, like me, before the Navy. Then you join the Navy, and now your mailing address has changed, right? Your fingerprint stays the same wherever you go, but your IP address, or think of that as your mailing address. Oh, I'm over here. I live here now. Forward my mail, give me mail at this address. You're still the same person, the same fingerprints, but then maybe you get orders to Bahrain or Japan, right? Your fingerprints are the same, but your mailing address is different. Does that make sense to everyone? So let's put that in. Cerna.
So on the actual says that the MAC address does not change, but on that video it said that they do.
So that's different, right? So this is for the device. So for the device, right? So for your laptop, your MAC address stays the same. When you go, and when you're at home, you've got an IP address. But when you go on a different network, right? You go to take your laptop to Starbucks, your MAC address stays the same, but your IP address, you're on a different network, right? But before in those videos, it was talking about, let's say your laptop sends a message to a server. Well, the IP address for that specific packet from your computer there, while it's transiting from your computer to that computer, the IP address stays the same, but at each router, that MAC address changes. For your device, your MAC address stays the same, and when you move your when your device moves from one network to another, your MAC stays the same, and your IP changes. But when your device is here and sending data, and your device is in the same place, but you're sending a packet, the IP stays the same, but that MAC address changes. So you got to think, right? If your device is moving from one network to another, your IP address changes. But when you're on a network and you're here and you send an email and the data, your laptop is staying in the same place, but the packet leaves, right? That's when the MAC address changes. Because, right? Think about the packet, right? Oh, it's physically on this device, but now I'm going to a router. Oh, I'm physically on this device to get there. Oh, I'm physically on this router. And I'm physically on this server, right? The MAC address changes because it's physically on a different device. Correct. But when you think about your device, right? That MAC address is the same because it identifies that device. Good, Cerna?
Yeah, that makes sense.
Okay.
That's why
Newton?
When you change the device, your MAC address changes. Is that what you're saying?
Correct. The MAC address uniquely identifies the device.
Okay, and then the IP address changes when?
When you change networks. So think of that as your mailing address. You?
Packet, what changes?
The MAC address. Because that MAC address identifies the physical device, right?
the packet is going from device to device.
Correct. Yep. How are we feeling? We okay?
That's why I was concerned. I had the same question earlier.
Great question, Cerna.
The same question earlier.
All right, so we already know, we've learned binary. We learned dotted decimal. Abdul Shakur?
So for the address format, are you gonna go deeper into it?
Yeah. So, but first, let's see what we know already. Like an IPv4 address is written in what? Dotted decimal notation. What are some things we already know about this IP address up here, 192.168.0.1? What class is it? What letter? Give me a letter. C, it's a Charlie, which means the default prefix is the right prefix is 24. That means 24 bits are turned on for the network. This is the host portion. We convert this from binary to decimal to get the subnet mask, which is 255.255.255.0. Now, the prefix, the subnet mask, what's the purpose of that? To identify the network portion, the host portion, right? What network it belongs to.
Small network.
This is a Charlie, right? That's a small network, up to 254 hosts. Now, this is an IPv4 address written in dotted decimal. How many bits in total is an IPv4 address? Well, how many bits are here? 8, 16, 24, 32. An IPv4 address is 32 bits long. Our MAC, Abdul Shakur. A MAC address is written in hexadecimal, right? That's 0 through 9, and then A through F. IPv6 is the same thing, hexadecimal, 0 through 9, A through F. The difference between a MAC address And an IPv6 address, a MAC address is 48 bits in length. An IPv6 address is 128 bits in length. Abdul Shakur?
So for the subject mask, all it is just it tells us which numbers are the host and network numbers.
Bingo. Yeah. What network does it belong to? IPv4 is 32 bits. Let's write this on the board. All right, everybody, an IPv4 address, how many bits? 32 bits. Probably should do a lowercase b. IPv6 is how many bits? 128 bits. A MAC address is how many bits? 48 bits. IPv4 is in dotted decimal. Both MAC and IPv6 are written in hexadecimal. IPv4, 32 bits.
32 bits.
So see a bunch of people writing IPv4 is 32 bits. Actually, Chief, if you want to pull up a notepad, maybe, and just write that down.
What you got?
You can erase that if you want. I got it all written down. Question, yeah.
How are they counted? Like, how do you, like, from the format numbers, how are they counted to the bits?
How do we figure out how many bits there are?
Yeah.
So, well, let's wait until we put an IPv6 address up, and then we'll explain that then. Does that work for you?
That works.
Okay. And if not, just ask me then, okay?
Okay.
Because we're going to do, remember that video they showed IPv6 compression? I'm going to demonstrate that for you all.
And then when it shows like the slash, like 24, that's just how many bits are on in the network.
The prefix, how many for the network? Yep, the network portion. And it works the same for IPv6 with that prefix. That's perfect, yeah. And then maybe add dotted decimal for IPv4, IPv6, MAC address, hexadecimal. That's what they're writing down now. Yep, MAC address and IPv6 are hexadecimal.
So that means it's like, it's not the binary code itself.
It's the,
That we did? The one that has the
it's like letters and numbers.
So wait, what's the one that we did the other day with the binary? That's also not
This here? So you got binary. We did both. Binary is the ones and zeros. Just numbers is decimal. And when we've got 0 through 9, A through F, that's hexadecimal.
Wait, you said if they have letters, it's hexadecimal?
Let's do this. Hold on one second. Newton, does that help at all? Good? Okay. No, you're good. If you ask a question right, with a class this size, you're not the only one that's got that question. So good on you. And Cerny, you had a question.
So, your MAC address is your physical, like, for your physical location.
Yep.
How would that change if you're sending data? Since you're
So let's say you're not a computer now, but you're a packet. And you're sending a packet to a server, right? That packet, right, when it leaves your device, it goes to a router. It's physically on a different device.
okay. So
Right.
Is the MAC address based just off the data?
We're going to get more into it in CCNA. Just hit that I believe button for now.
Oh, yeah, I believe that. I like that.
CCNA is going to be fantastic. Good? Okay, we're ready to move on. Question, Newton.
So the A, it stands for 10.
A is 10, yep.
I mean 11. Sorry.
A is 10, B is 11.
Oh, you're right. So instead of writing so 12 just means 12. But when you see like 3
Somewhere.
The E means 14, so this is 3, and this is 14.
okay, so what is the number in front of it? Just a number?
Yeah, it's just a number, right? The A is 10, this is 11, 12, 13. This is a 1, this is a 2. It's a 1 and a 2.
Because if it was a
Yep.
12, it would have been.
That's why I was like, why is there a 12?
I see. No, it's 1, 2, right? Because 12, C is 12.
Maybe 10, 11, 13, 14.
10, 11, 12, 13, 1, 2, 4, 13, 3, 14, 1, 2. Jackson. Just stretching. Okay, we'll go back to the slides. Bit off track, but that is okay. Does the difference between a MAC address and an IP address make sense? For your device, what stays the same? For your PC, the MAC address. What changes when you bring your laptop to Starbucks versus take it? IP. Good to go?
If you're sending something to a switch or a router, your MAC address is going to change.
Not for that device, but for that packet that's leaving. That's right. Yeah.
So I'm locked in.
All right, we'll scroll down. I think what's next is... All right, we've already gone over IP addresses. So I think next is IPv6. Scroll down a little bit. Yep. Let's get a brand new marker for this. First, on a Windows device, we know that there's two ways to navigate. There's the GUI, the graphical user interface. That's got the mouse, allows us to click on things, etc. The other way, the OG original way to navigate computers with what was called CLI, Command Line Interface. So Chief, if you could pull up command prompt for us. And we're going to deep dive into this in later chapters. So this is just a one-off example of command prompt. And we're going to learn a bunch of this. Abdul Shakur?
So, isn't it like protocol that like change the host name? So I don't know if you do
NetBIOS.
my to your head.
Yep, we're not talking about that at all right now. Nope. All right, so this is, never mind, we'll go back to the slides. No, we don't have admin rights. All right, so in command prompt, I love my VM. If you type in the command ipconfig /all. Now this command works for Windows devices, not for Macs that run off of Linux, and we'll explain that later. Roberts.
I interrupt. It was just about what you had written on the board. I was about to write it down, but it got erased. So, which module is it where you were saying 9, 10, 11 is ABCD,
Hexadecimal.
And hexadecimal.
Hexadecimal, yeah. Do you want us to put, we got it on a notepad. Do you want the notepad back up?
I would love to know.
Yeah, Chief, can you put that notepad back up? And then we'll pause for a second. You already got that? Good? Okay. What's that? Yeah. It'll go up today. Well, I don't know what time you start studying, but by 7, it should be up. Good? CLI, command line interface. Yeah. The original way to navigate is command line interface. So what are we looking at right now? That's command line interface. Later chapters we're going to be doing this, and we'll re-explain what it is then. But for now, if you want to view your IP address, you want to view your MAC address, you can do that. And anything you can do in the GUI with your mouse and the pictures, you can do in the command line interface. And we'll explain a lot of that and demonstrate it, and you're going to do some of that as well. But for now, on a Windows device, if you want to view your IP configuration, you type in ipconfig. That'll give a lot of information. The common one we do is ipconfig /all, and we'll dive deeper into different commands we can do for DHCP, etc. So when we do this, you can see a bunch of information, your host name, etc. What we're looking at here is, here is an Ethernet adapter. Now, if you've got multiple Ethernet adapters or NICs on your computer, there's going to be a lot of information. There'll be the Ethernet adapter here and all the info, and then more down and more down. Well, why would you have multiple NICs on your computer? Well, your computer might be able to connect wired with 802.3, wirelessly with 802.11. If you've got a virtual machine, it'll have a virtual NIC. So you may have multiple information in there. Hoo-ya? So let's break it down. If your computer just has one, which a lot do, we've got this, our physical address. What's a physical address? MAC address, which is what layer address? Layer 2. I can see DHCP enabled? No, that means I have to statically assign an IP address. Speaking of IP addresses, here is my IPv4 address. Right here, 192.168.200.8. What class IP address is that? Alpha? Bravo? It's Charlie. What's the default prefix for a Charlie? Prefix. 24. 24 bits turned on for the network. Convert that from binary to decimal. Get our subnet mask. 255.255.255.0 Newton.
What do you mean statically? Is that when you talk to DHCP?
Manually. Static. Manually. I had to go here to do it. I got to go here to do it. So the opposite of static or manually is dynamically or automatically, which is DHCP.
Oh, automatically?
Is DHCP. Correct. Dynamically, automatically, that's DHCP. Correct. Statically, we're going to go in that in just a little bit. That's what's coming. Cerna?
I was wondering about the IPv6 and IPv4.
We're going to get into that in just a second. Yep, just answering questions before we get there. Hoo-ya? All right, so continuing with this is command line interface. This command, what was the command we did on Windows to view this? ipconfig /all. So I got my physical address, which is my MAC address. Now, how is this written? Is that binary?
That is
That's hexadecimal, right? Here's my IPv4 address, 192.168.200.8. We said that's a Charlie. Is that private or public? That's private, which makes sense because this is probably on a LAN, right? Now here's my subnet mask, which is the default for a Charlie. What's the purpose of a subnet mask? The host and the network portion, right? Here is my IPv6 address. What is this written in? What format? Hexadecimal. Very good. We'll get into more of that stuff later. And my default gateway, I've got one for IPv4, IPv6. What is a default gateway?
router.
That's the router, right? That's how I get out of my network. But if I've got a router, it's probably going to have multiple IP addresses on it. which one is going to be my default gateway? The internal one, right? Just like the door is our router or how we get out of this network. To leave this room, we open the handle on this side and go out. We don't go like the Kool-Aid man. Oh yeah! Go through the wall and come around and reach on the other side, right? Does that make sense to everybody? Okay. Questions on this? What command did we do to view my MAC address? ipconfig space/all. All right, what command did I do to view my physical address? ipconfig space/all. What command did I do to view my IP address? ipconfig space/all. What command did I do to view my default gateway? ipconfig space/all. What about my IPv6 address? ipconfig space/all. Very good, right? Because we've only learned one command so far. Grace.
And this is once you get in your command line interface, right?
Correct. This is in the CLI or the command line interface. Good? Okay. COE? Co?
So the default gateway, are both of those to the same? They're just different formats.
One's IPv, same device, same interface. One's IPv4, one's IPv6. Good question. What else we got?
The default gateway, that's always going to be the first open client spot.
Yep, you just like, if that door is my router, I've got an IP address on this handle, I got an IP address on the handle on the outside. Just think about this device, right? And follow that line on the topology. How do I get out? Just follow it, right? Oh, it's the IP address on that handle closest to me. No, we'll get into that in CCNA though.
Why the IP address is changed to because of the router IP address is changing?
The router's IP address usually doesn't change because you wouldn't want to, how do I get out of this classroom? I go here, and then tomorrow it's here and here. Your computer might change, but intermediary devices, routers, switches, even servers, you don't want those to change. But that's a little bit more CCNA 2 kind of stuff there. Are we ready to go on? We need more time for notes. All right, the next slide is here. So on a Windows device, on Monday, we're going to load our virtual machines. I'm going to show you how to statically assign an IP address on your virtual machines when we download those. We're also going to go into Packet Tracer, and you're going to see how to do it on there as well. Now, Packet Tracer doesn't emulate or show real life how it's done, so the virtual machine is going to be more relevant for real life, what you're going to have to do in this course, etc. Packet Tracer more for CCNA. But we can see here, when we get in there, use the following IP address. Is that static, manual, or is that automatic DHCP? This is static, right? This is you saying use this IP address. You put in the IP address, you put in that subnet mask to identify the host in the network, and you put in the default gateway, which does what? The router, so that way we can leave. So if I don't have a default gateway configured, or if it's misconfigured, hypothetically, can I communicate inside my network? Yes. Can I communicate outside my network? No. Definitely not. Newton.
How do they get these numbers? Do they just pop up like this, or do you have to go in?
So it's statically, so you'd have to come up with it, and in CCNA we'll learn how we come up with those numbers.
Oh, okay.
So for now, just it would be given to you. In CCNA we'll learn how to figure those out.
Like I just go put it in.
Yep.
And then press use.
Bingo. Yeah. For this class, I will give you the IP address. I'll give you the subnet mask. I'll give you the default gateway. I'll give you the DNS server. You don't have to do any of that. In CCNA, we'll do a lot of work to get there to how you figure that out. Good to go? Okay. Now, if I wanted to use DHCP, what are the port numbers for DHCP? 67, 68. Which one's for server? 67. Which one's for client? 68. So if I want to use DHCP, boom, I hit obtain an address automatically. So instead of going to each computer, it can just go out and get it itself. Now, if I do that, if I want to get an IP address automatically, what kind of message is the computer going to send first?
Request.
Dora. D-O-R-A. Discover. Offer. Request. Acknowledge. We all remember that from yesterday?
Yes.
And that chart we did? Awesome. Abdul Shakur.
For me to understand the door part, isn't it like you ask somebody, hey, can I get that shirt? They'll be like, yeah, you want this shirt? And you tell them, yeah, I want this shirt. And they give you that shirt.
Bingo, right? But maybe think of it more of as like, hey, I need a shirt to everybody. And then somebody's like, hey, I got a shirt. And they say, okay, I'll take that shirt. And they say, okay, here it is. We've got multiple, not just a specific. Bingo, it's a broadcast message. That work for you, Abdul Shakur? Good? Okay. Then below that, we've got a DNS server. Why might we need a DNS server? What's DNS do? Domain name, service, system, server. What's it do? Translates the URL to an IP address, right? Now, if you don't have a DNS server IP address, that means instead of typing in Instagram.com, you've got to type in whatever IP address that is. So you've definitely got to have this. Good to go? Yeah, we're going to go over that command later. Hoo-yeah? Awesome. And we'll see how to I'll demonstrate this later in Packet Tracer. All right, moving on. You'll hit OK, and we'll go into this in a little bit. We know the purpose of a subnet mask is to
Identify the network and the host.
the network and the host portion, or which network it's a part of. All right, next, IPv6 addresses. Ready? I'll give you a second. We're going to do a bunch of board work here.
Somebody can say that number on the
340 undecillion, 200. Oh, I don't count? And we talked about IPv4 versus IPv6 already, right? There's about 8 billion IPv4 addresses. We were going to run out. So they did NAT, the private non-routable, for alpha, it's anything that starts with 10, Bravo 172.16 through 31, Charlie 192.168. But for IPv6, 340 undecillion addresses. Have we not talked about this yet? I thought we did, right? We're not going to run out of IPv6 addresses. We'll emphasize that more again when we get to CCNA. But for now, we're going to go over IPv6 compression. So if you want to see the board, I would move up. Ready? All right, there are two rules for IPv6 compression. Rule number one is remove leading zeros. A leading zero, if we break down one of these, if I have 0, 0, A, 0, these are leading zeros, so we can remove these. But this is not a leading zero because it comes after a character, a number, or a letter. Does that make sense? Okay, now if I've got 4 zeros, 1, 2, 3, 4, I'm going to remove the first 3, and we'll explain why when we get into the second rule. Good to go?
Is that just like section, I guess?
Hextet. These are hextets because there's 16 bits in each one. Yeah, let's break that down. Let's go back to our hexadecimal days.
Oh, yeah, 'cause that's how I.
So this 2, how would we convert that 2 into binary? Hexadecimal works with how many bits? The nibble, right? How many bits are in a nibble? 4, right? So the value of those bits are 1, 2, 4, 8. So this would be 0, 0, 1, 0. So how many bits are here? 4. How many bits are in the first 2 then? 8, right? 0, 0, 0, 0. Here, this 0, 8, 4, 2, 1, 0, 0, 0, 0. And this over here, 8, 4, 2, 1, 0, 0, 0, 1.
Where did we even get 8 or 2 1?
Remember back when we did hexadecimal? So this is how hexadecimal works. It's 4 bits, right? So here there are 4 bits. 1, 2, 4, 8 are the value of the bits. So that's each hex character is 4 bits. Right? Like this A, there's 4 bits here. 1, 2, 4, 8. A is 10, which is 8 and 2. And we did this all the other day, right? Don't worry too much about that for now. But if you want to, let's see how many bits then are here. Just in that character, how many bits? 4. Okay, if we move out to here, how many bits now do we have total? 8. This is 12, and then this is 16. So in this is called a hextet. There are 16 bits. All of them have 16 bits. So this is 16. Now how many do I have here? 32. Now out to here we have 32 plus 16, 48. Now we have 64 plus another 16 plus 16, 96, all the way out to 128. Right, so an IPv6 address is how many bits long? 128. If you can't remember this, right, let's look at an IPv4 address. 192.168.0.1. How many bits are here? 8. There's 8. There's 8 here, right? Octets plus 8 plus 8 plus 8. An IPv4 address is how many bits? 32. How many sections are in an IPv4 address? 4. Okay, so if you can remember this, now let's look at our IPv6.
Wait. I have to go to 8. Because I think does it start from 2? Like 2?
192. 1, 2, 4, 8, 16, 32, 64, 128. This is an octet. There's 8 bits. Or an IPv4 address is 32 bits. 32 bits divided by 1, 2, 3, 4 sections is 8. I've got 8 here, another 8, another 8, another 8. 8, 16, 24, 32. An IPv4 address is 32 bits long. This is written in dotted decimal, but we could also write it in binary, which we did the other day. For you, all you need to know, right? How long is an IPv4 address? 32 bits. How many bits are in each octet? 8. How many octets do we have in IPv4? 4. Okay.
And that's all we need to know?
That's just, yeah. So, how many bits are here? 8. How many are in IPv6 in each section? 16. So this is twice as many, right? Okay. How many sections do we have here? 4. Here we have 1, 2, 3, 4, 5, 6, 7, 8. So there are twice as many sections in IPv6, and each section has twice as many bits in it. Hextet. Hextet.
That answers my question.
Good. Abdul Shakur? Are in each octet. Correct. Yeah. Okay, so let's go back to what we were learning, which was IPv6 compression. The first rule is omit or remove leading zeros. So if I have 0, 0, 0, 0, I'm going to remove the first three. If I have 0, 0, A, 0, I'm going to remove the first two, but I'm going to leave this because this is not leading. Good? Now that's because if I just have A0 and I tell you to decompress that, well, how many characters are missing? 2, right? And if they're always compressed this way, we know what's missing is 0, 0. So let's do this. Step 1, we'll do several examples. You all yell out when you want me to erase a 0. Huya? This one? No. This one?
Relax.
Good? Okay. So that leaves us with 2001 colon 0 colon 0 colon A0 colon 120 colon B colon ACAD colon 120. Huya? Right? And we're humans. We want to be lazy, so this is going to be easier for us to type. Now the second rule is remove 0 segments. But this is a one-off. You can only use it one time. So here, I'm going to replace these with a double colon. And now that leaves us with 2001 colon colon A0 120 colon B colon ACAD colon 120. It's going to be a lot faster for us to type this than this up here, right? Second to right, and then we'll do another example. Not Colin. Colon. Correct. And we'll do that in the next example. Abdul Shakur? It's not because it's 2 zeros. We'll do another example. It'll make more sense.
Oh, because the zeros are because they're right next to each other?
Oh, no. We're going to do another one. All right, first rule is remove leading zeros. You let me know when I erase or cancel out, whatever. Why not this one? Not leading. Not leading. Okay, so that leaves us with 2001 colon 0 colon 0 colon A0 colon 0 colon B1 colon C0. Now, rule number 2, remove 0 segments. I've got a 0 segment here, here, and I've got one here. and I can replace these with a double colon. I could do this one first, and that would be 2001, colon, colon, A, colon, A0, colon, 0, colon, B1, colon, C0, because I can't have two double colons. Or I could do the double colon here instead, which would be 2001, colon, 0, colon, 0, colon, A, 0, colon, colon, B1, colon, C0. Now, technically, this first one is shorter, right? So this one's going to be more correct. But you could do either or. Do we want to see why we can only do the double colon once? You all want to write this down? Okay. Let me get some water.
I'm confused on why the bottom one, you did 2 colons for that third 0, but then the top two, they also did.
So for this one here, I replaced these with a double colon because I can only do double colon once. So that means this had to stay. For this one, we left these, and I put the double colon here for that one there. We're going to do more examples.
Okay, so like I get it, but like why can we only do?
We're going to do that next once everybody's done writing. Why we can only do it once?
Yeah.
So what if you also had like, you say that the fourth section was also like.
We'll do a few more examples. Good. And I'll show you your IPv6 loopback, which is very short.
Can you only do the 0 without the double colon?
You can only have double colon once, right? So if you saw an IPv6 address 2001 colon colon 1 colon colon 2 colon colon 3, well, there's double colon once. That's wrong. That's wrong. That's not a valid IPv6 address. I think we do a few more examples. It'll make sense. Schreier.
I just have a question because can you combine so those 2 zeros are next to each other, right? Can you combine those into the double colon?
We did, right? That's what we did. This first one, we did here. The second example, we did this 0 here. Correct, yeah.
So if there's 3 zeros next to each other.
We're going to do that example here soon. Yeah. Double colon can only be once. Every IPv6 address, the double colon, you can only use that once. And let's see why. Because these questions will all be answered with more examples. The same question. Yeah. Awesome. Okay. Make a noise when you want me to erase or cancel out. First. First 3. All right. That gives us 2001 colon 0 colon 0 colon A colon B colon 0 colon 0 colon C. Good? Now, double colon. How many times can I use that? Once, right? Let's do it incorrectly and see what happens if I replace this with a double colon and this with a double colon. That would be incorrect, which is 2001 colon, colon, A, colon, B, colon, colon, C. This is wrong. But I've got how many sections or hextets? 1, 2, 3, 4, right? How many hextets or sections are there total? 8. So how many are missing? 4. Okay, so is it, just with this, you don't know what this is it 2001, colon, 0, colon, A, colon, B, colon, 0, colon, 0, colon, 0, colon, C? 1, 2, 3, 4. Or is it 2001, colon, 0, colon, 0, colon, A, colon, B, colon, 0, colon, 0, colon, C? Is it 2001, colon, 0, colon, 0, colon, 0, colon, A, colon, B, colon, 0, colon, C? Which one is it? We don't know, right? Is it 1 here and 3 here? Is it 2 and 2? Is it 3 and 1? There's too many options. They're not going to be able to decompress it, so we can't do this, right? But instead, let's say I wrote it 2001, A, B, colon, 0, colon, 0, colon, C, only using the double colon once. 1, 2, 3, 4, 5, 6. How many are missing? 2. So that means it's 2001, 2, 2 that are missing, right? We can fully decompress it. See why we can only use it once? This? This one here? 1, 2, 3, 4, 5, 6, 7, 8. Let's do that on the board, or something similar. All right, let's do another example. Everybody good? All right, make a noise when you want me to get rid of a 0. Or say first 3 if it's the first 3. First 3. First 3. First 3. First 3. First 3. Okay. Good? That gives us FE 80, colon, 0, colon, 0, colon, 0, colon, 0, colon, 0, colon, C, colon, D. The second rule, we can get rid of this with a double colon, which gives us FE 80, colon, colon, C, colon, D. Right? Because I've got 1, 2, 3 hextets or sections out of how many? 8. So I'm missing how many? 5. 1, 2, 3, 4, 5. Does that answer your question? You had your hand up first.
So, you can do that if all of the zeros are so say that middle 0 is a 1. You wouldn't be able to
Yeah, if this was a 1, then you could do FE 80, colon, colon, 1, colon, 0, colon, 0, colon, C, colon, D. Or you could do it the other way. FE 80, colon, 0, colon, 0, colon, 1, colon, colon, C, colon.
So it only works if they're like right next to each other then.
Correct.
After consecutive zeros. Good one.
Jackson, I think you were next.
Same question.
Good. Line 2. The double colon, but you can only use it one time.
So can you flip it and like have
Oh, I did that example for him over there already. Yeah, yeah.
so like
Yeah.
say if it was FE 80, but the C and the D were right here, and these
Let's do some more examples. How about that?
all zeros. Can you just put the colon, the semicolon at the end?
Yeah, let's do some more examples. We're just gonna do a few more examples. All right, next example. Here, 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 here. Score. Here, here, here. Okay, so that reduces us to, perfect, thank you. 2001, colon A, 0, 0, 0, 0, 0, 0. We can replace all of this with colon, colon, which gives us 2001, colon A, colon, colon. That's right. Let's do another one. This is an address we've talked about already. What am I doing here? First three. Here. 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 That gives us 0, 0, 0, 0, 0, 0, 0, 1. We can replace all of this with colon, colon, 1. Does anyone remember what address this is for IPv6? This is my IPv6 loopback address. Colon, colon, 1. What does that mean? 127 zeros and 1 1. Another example? We're getting it now? We just needed more examples, huh? Okay.
I started writing down problems for him to solve.
Anyone a second? Cheng. A PIPA? A PIPA we're going to talk about when we get back from our break. That's our link local. If I'm configured for DHCP, but I can't get to a DHCP server, I need an IP address. So I'm going to get an automatic private IP address, which starts with 169.254, whatever, whatever. That's in a PIPA or link local. I can't communicate outside my network. There is, yeah. Yeah. I'm not going to talk about it's FE80, but I'm going to teach that when we get back. It's not a loopback because it's compressed. It just happens to be compressed. Remember with IPv4, our loopback address, 127.0.0.1, that tests my TCP/IP network stack to my NIC, but it doesn't leave my NIC. Same for IPv6, that tests my TCP/IP network stack to my NIC, but it doesn't leave my NIC.
So it tests itself?
Tests itself. We feeling okay? Yes. We want a break?